got 2 more demonstrations. They're not going to be that long. I'm going to do one more demonstration in Earth Engine, and then I'm going to do the last demonstration using an application called Climate Engine, which I just want to show very briefly what this application is. There's a lot to explore on your own with this application, but I do want to I want to make you aware of it so that you can come back on your own and explore for yourself. So the next code that I've created for you, and I shared it in the presentation that you have access to, is called JRC Global Surface Water. And I'm actually going to switch back to presentation. Okay, so real quick summary of the previous, the Google Earth Engine platform. Real quickly, let me go to presentation view. It provides users with cloud-based computing resources. The capabilities of Earth Engine are similar to those of many GIS platforms. I've had a few different questions about, the things that I'm doing in one application. Can I bring it into Earth Engine? And my initial response is you definitely should be able to. I haven't done it, so I can't with 100% certainty say yes, but you should be able to, based on the computational power and the algorithms that are built in, or the algorithms you can add to. So you should be able to do almost everything in one application, say like QGIS or ARC or something else in Earth Engine. And I've been demonstrating everything in JavaScript API, and that enables JavaScript coding and automation of basic remote sensing for processing large voluminous imagery. And then users interested in the Python API, if Python is your preferred language, definitely can explore Google Colab. And there's a lot of material out there to learn about how to do that. And let's see, and then session 2, we covered land cover classification and accuracy assessment. In this slide here are links. So if you want to learn more about land monitoring applications, you can check out this RSET training, actually 2 different RSET trainings for the links there. And those links are for the English material, but you can also access that in Spanish as well. And then something I'm highlighting here is the Docs tab. If you have Earth Engine open, if you see the tab on the top left-hand side of the window, there's in the top left-hand, there's a few different tabs. One of them is scripts. The middle one is docs. And a lot of the functions and a lot of the algorithms that you'll be applying to the imagery, you can read about. So if you're curious, oh, what does that do? Or what does this do? You can go to that and use it as a reference. So I just wanted you to know that that's there for your reference. And then the links here on the developers guide and then the Earth Engine developers group, these are resources that you can use. The top one is created by Google Earth Engine just to get more familiar with the application. And then the developers group are from people from all over the world asking the same questions that I'm asking, that you're asking. And so it's a way of crowdsourcing it with people within the community that want to learn more. So those are really good resources if you want to learn more about specific applications or just generally about the Earth Engine. So I'm going to give a brief demonstration, thank you, Perry, on surface water acquisition in the La Plata Basin. I believe this is probably of interest to many here because this is your basin of interest. In the slides that we provided, I provided a code at the top. That code is to the demo, which I'm about to show you. And then the data set is to the data set, the generator of that data set. That's the group, the JRC group that actually created the surface water data set. And they created that data set using Landsat imagery from 1984 to 2021. So it's a long time series of surface water and it's global, but in this code, I have tailored it to be just for the La Plata Basin. And So that's what we're going to show here, is this data set. And if you want to learn more, if you want access to the code, or if you want to learn more about how the code was created, these are links that I will provide. So I'm going to jump back over into Earth Engine. And I'm going to go ahead and click run. So I'm going to break down exactly what's going on in this code. I'm going to move somewhat quickly because I've introduced a lot of these concepts to you already. But right off the bat, I've defined two different variables. One is a variable that I actually created. I drew a bounding box. I created a rectangle in a specific area within La Plata Basin that I wanted to generate a histogram for. And so I will zoom into that area a little bit later, but I actually created this, and I gave it a name, ROI, which stands for region of interest. And I created another variable, which I named La Plata, and that's the same shapefile, that same polygon that is the boundary for the La Plata drainage basin. So those are two variables that are defined at the top. And then the next section is just commenting, saying, you know, this code is open source. And if you want to learn how the data set was created, there's actually a really great article in Nature journal. And so you can read specifically how the methods that they used and the accuracy assessment that they performed. So you can read more about that, as well as a link to the source, which is you can find on Earth Engine. And then this next chunk of code are defining more variables. I defined one variable, GSW, that's global surface water. And so I defined that variable, and that took that data set, which is from, again, surface water from 1984 to 2021. And then I defined a second variable, GSW clip, which is global surface water clip. And I basically took that shapefile, that boundary of La Plata Basin, and I subset that global data set just for the La Plata Basin. And then I defined three other variables. And these three variables are corresponding to bands that are within that global data set. Those bands are occurrence. That's the percentage of occurrence throughout that time record from 1984 to 2021. So of all the pixels where that water has been, what is the percentage that it was there throughout that entire time series? And then there's another variable, absolute change, that is defining another band within that data set, and then transition. So those are seasonal transitions throughout the year. And again, I specified I wanted the base map. That is what's below the data set that I'm bringing into Earth Engine. I'm just defining that base map will be an image, and it's not going to be that default base map when you're using Google Map, whatever that map image, or it's not even an image, whatever that map is. I'm saying I don't want that. I want an image so that I can actually compare it to what I can see through an image as rivers and lakes, etc. Next, I'm going to center the map on the shapefile, and then I'm going to define different variables for the colors I want to use for each of the bands when I add them to the map. So that's what this next chunk of code is, just creating the visualization for those different bands. And then again, it seems a little silly, but probably the most difficult part of this whole code was just creating a legend, which is just ridiculous. But it's really not that difficult, but it's just ironic that it's probably takes the most time. It's just creating a legend. It's not even like, you know, having this access to this incredible data set and querying it and doing what you want. It's just creating, and you don't have to create a legend. I just, you know, why not? Especially if you want to share it with colleagues. All you have to do is, if you can see on the top of this, on the top of this where you can see get link, you can just click that, or you can just share the link to the code that I've shared with you, share it with your colleagues. They have access to this. Again, this is creating a function, creating a for loop, which is basically just assigning the information classes to the different colors in the legend. And then we're just adding that legend. And then this is creating a calculation. So it's creating a water mask, and it's saying, I'm defining a variable. I'm going to label it water mask. And I want to say anything where water is occurring greater than 90%. I want to mask that out. So that way I can that way I'm just returning things that are within that parameter. And then I'm creating a histogram, and I'm creating a histogram for the bounding box, that rectangle I drew along one area on one tributary. I think it's to the Uruguay River. I created a special bounding box just if I wanted to look at a histogram as a good way to explore the data, just to see the spread of value within the area of interest. So I really did that. I could have done it anywhere. I just randomly chose a spot just to show you how it's done. But you can certainly edit and modify this code. I really just did it it's more of a proof of concept, so you know that you can do it and that you can modify it. And then I gave that histogram a title, and then added it. And then basically this next line of code is a 2-band image where the first band contains the area information in units of square meters, and the second band contains the transition class information. And that's what this next chunk of code is doing. And then I am defining the visual parameters for the shapefile, just so that when it's added to the map layer, it has some way to visualize it. And then I'm adding all those different map layers. So those variables that I defined earlier, I'm now adding them to the map window below, and I'm also defining the visual parameters, as well as I'm giving it a name. And I'm also saying shown false. So you can see in this layers where the results are output to, you can see only some of them are checked. If I did not add shown false, they would all display. It's just a way of keeping your map window nice and clean and only displaying what you want, so you have better control over your code. And let's see what's up. And then this next line of code is showing the absolute difference in the mean occurrence value between 1984 and 1999. So basically the first, say, 16 years of code and the latter 19 years. And so just comparing those date ranges. And then I'm adding that to the map window. And lastly, I'm commenting out an area where I am allowing you to export the results to your drive, if you have a Google account. So this is just one way of viewing global surface water from 1984 to 2021. And it's showing the percentage of pixels. And if I can drag this up, hopefully we'll be able to see a little bit better in the legend. So these colors correspond to the percentage, or I should say the transition classes, if I turn that on. So these are the transitions between all those different years. So you can see where some of the seasonality has been lost, where some of the permanent water has been lost, where it's been gained. You can also look at water occurrence. This is the percentage of occurrence between 0 and 100 from on a pixel by pixel basis. So you can explore this all you want. There's an option here. If I can drag this down. Let's see, where is it? Oh, I need to drag this over. Please excuse me. I can use this inspector tab. And if you want to explore any of the values on here, you can go ahead and click on that, and it will give you the values of all of the different layers, the results from those. So it'll select the water occurrence. I randomly click on a pixel, but it said throughout that entire record, that pixel had water in it 84% of the time. And then you can also look at the absolute change in occurrence. You can look at the transition. And that transition again is in this legend. So you can compare it to that. And then also the water occurrence. So this is an incredibly brief demonstration, but it's a really terrific data set. And because it's such a long time record, you can really explore it. Maybe you're interested in a different part of the planet. But again, I just tailored it to La Plata River Basin. You all have access to it. I'm actually going to wrap up now. I'm going to save the other. I might not even give the other demonstration because we have such a packed week. And this is actually what I was afraid was going to happen. There's just so much we're trying to cover, which is not a bad thing. But I will say, and in the slides that you have, that you do have links to a incredibly powerful application, which is called Climate Engine. This was created through funding from NASA, and it's built off of the Earth Engine platform. And it's also funded from research groups like the Desert Research Institute, which is based in the state of Nevada in the United States. And it's also other players that help support this. But it gives a very nice user interface. So you don't have to do any coding, and you can produce graphs, and you can also produce a lot of climate anomalies. So if you're looking at maybe some of you are interested in soil moisture or the Palmer Drought Severity Index or the Standardized Precipitation Index, if you want to start looking at anomalies for your study area, you can use a graphical user interface and just using the drop downs that are here. So if you can use climate and hydrology, if you want to look at remote sensing, they also have the Landsats and the MODISes and everything else. And you don't have to do any coding. And you can very quickly start identifying anomalies in your study area. And you can also start outputting graphs based on those anomalies. And you can also download them. You can't download them as GeoTIFFs, unfortunately, but you can download them in other formats and as CSV files, et cetera. So I don't have the time because I've actually run out, and I'm sure you're tired of listening to me anyway. So I'm actually going to hand it off back to Perry. So if I can bring Perry back up here. But thank you guys so much for your attention. I really appreciate it. And I do hope you look into Climate Engine on your own. Thank you.